Solve the differential equation xy prime minus 3y equals x squared with the condition when x equals 1, y equals 2. First, we rewrite it in the standard form. Y prime plus pxy equals q of x, where px is minus 3 over x and qx is x. This is the first order linear differential equation. The integrating factor is e to the integral of p of x dx, and so the integrating factor is e to the integral of minus 3 over x dx, which is e to the minus 3 ln of x. Rearrange this, we get x to the negative 3. We then multiply x to the negative 3 to both sides of the differential equation in the standard form. And then we simplified it, but we guarantee that the left-hand side is the derivative of the integrating factor times y, which is this. Notice that if we were to take the derivative implicitly, we will get x to the negative 3 y prime minus 3 x to the negative 4 y. And so x to the negative 3 y must be the integral of x to the negative 2 dx, which is minus 1 over x plus c. Isolate y, we have x cubed times minus 1 over x plus c, which is minus x squared plus c x cubed. But with the initial condition when y equal 2, x is 1, substitute x equal 1 and y equals 2, we have c equals 3. So the particular solution is y equals minus x squared plus 3x cubed. And we can always check to make sure that we have the correct solution by differentiating y to get y prime to see if it is in this form. To solve the linear equation of the form y prime plus pxy equals q of x, we always multiply both sides by the integrating factor e to the integral of p of x dx and integrate both sides. The left side is guaranteed to be the derivative of I of x times y. Solving the initial value problem. This is the first linear order differential equation given the initial condition when x equals 1, y equals 2. Observe that this is the first order linear differential equation where p of x is 1 minus 1 over x and q of x is x squared. So the integrating factor is I of x equals e to the integral of p of x dx, but p of x is 1 minus 1 over x. This is e to the x minus ln of x, which we can simplify into to e to the x times x to the negative 1, which is e to the x over x. We then multiply the integrating factor to both sides of the linear equation in the standard form. And we guarantee that the left-hand side is the derivative of the product of I of x, which is the integrating factors, and y. We can verify this by implicit differentiation. The derivative of e to the x over x times y is e to the x over x times y prime, plus the derivative of e to the x over x times y. But the derivative of e to the x over x, we use the quotient rule. And so we end up with e to the x over x times y prime plus e to the x factor out times x minus 1 over x squared times y. Notice that if we were to factor out e to the x over x, we end up with 1 minus 1 over x in the second term. And so e to the x over x times y must be the integral of x times e to the x dx. But we can integrate the right-hand side by integration by parts. And so e to the x over x times y equals the antiderivative of x times e to the x is xex minus e to the x plus c. And then we isolate y to get x squared minus x plus cx over e to the x. But the initial condition is when x equals 1, y equals 2. And so plugged in x equals 1, y equals 2, we solve for c equals 2e. So the particular solution is y equals x squared minus x plus 2 times e times x over each of the x. With the first order linear differential equation, we always find the integrating factors first, which is I of x, and we multiply I of x to the left-hand side and the right-hand side of the differential equation in the standard form. It is guaranteed that this left-hand side is going to be the derivative of the product of I of x times y.